Good afternoon once again. We continue from where we left in the last video about the PASAX correlation analysis. After taking a look at the RHB and Takaful stock comparison, which the raw time series looks very similar. So it agrees with what we found during the principal component analysis, which is no coincidence because we are using, which is just a mathematical way of different representation. But uh, what we would like to state over here is that in terms of plot also, although PC2 do not fully represent the time series, still the similarity is being carried forward. So which is still good. It is good to use the PC2 for these two stocks for further analysis. That's what we can conclude. Now, PC PC2 for RC Capital, TA, and Tune Protect were very similar in the principal component analysis, right? But what we found in our PAA SAX analysis over here using the synthetic time series modeling, that's not the case. Actually, the time series are very different, very dissimilar, and that so this is a conundrum inside a conundrum, I would like to say. So we started with the hypothesis evaluation, whether the conventional logic that a stock from a particular business segment, stocks from particular business segment, whether they can be grouped together and are they similar. We found out that need not be the case by doing the principal component analysis, which told that no, does not have to be the case always. It can happen, it cannot happen. So the chances of happening, not happening, 50-50. Coming to after PCA, we found during PCA we found that whilst the hypothesis is not true, but then there is something else that is true, which is the stocks of RC Capital, TA Enterprise. They are very similar to the insurance company, which is Tune Protect. But then again, when we take that assumption forward or the judgment forward, come to the SAX representation, that is not the case. So you can see that when we plot the PC2 for the TA enterprise, we plot that for the RCE Capital and Tune Protect. They are very dissimilar. You can see from the plot in RCE, it is already like a square waveform and it is very noisy. It has got a steady squarish pattern, but it's very noisy. Coming to Tune Protect, it's got a another unique pattern of its own, and then compared to the TA Enterprise, which is also very different from the both of them. So our judgment that we made in PCA does not hold when it comes to the representation in SAX. So that's the nature of data mining and analysis and that is the very reason why that you should never rely on a single methodology to base your judgment. Like we decided that what patterns we see in PCA, let us verify using the independent method, which is the time series approximation. And here we find that is necessarily not true. And then coming to public bank, we never had any kind of grouping in PCA also or during the discussion that time. But if we look at public bank, it has got its own unique series, but it needs to find its own group and pack. We don't have those stocks yet, but this public bank synthetic time series could become like a some kind of a reference uh, signature, like a thumbprint or a thumb impression, which can be used to find the patterns of time series that behave this way, and then we can try to compare them against public bank, and then instead of coming from PCA to time series, we can go backward, that we compare time series, we cluster them, and then we try to put them back into the PCA and see whether the PCA, the principal components that describe those series, are similar or not. So there is a lot of discoveries in a very creative and innovative way that you can do by either coming from one method to different method or going backwards. That's the beauty of data mining, that you can it's very flexible, so long as you keep the entire maths, underlying maths, intact, and you don't try to change the maths at any point in time. If you could manage to do that, then data mining allows you to go from, gives you many possibilities to move. There is no rigid path. Lastly, we come to the the most exciting part, which is, at least for me, which is the symbolic representation of the time series. It's like representing the musical notes on the notebook, right? So in this case, we have this is a real time series, uh, in which the real time series of the RHB, which is the raw time series that we saw here, using the PC2, that raw time series, this particular plot, it shows how that raw series has been broken down or simulated or modeled using the symbols. So we used the symbols, which are 10 symbols, 10 A, B, C, D, E, F. Sorry, 6 symbols, 6 bins. So yeah, sorry, 6 symbols we used to represent that was enough. The horizontal lines that you see over here, those are the bins. Those bins, when we go to the code, we will see that those bins have been selected. They are like normal bins. Uh, why we selected normal bins? Because we wanted to capture equiprobable distribution, but we can choose the bins in a different way. Also, we can choose different style like a uniform bin, so they just divide this entire window from 4 to -1 into equal number of bins, and then it will represent the symbols accordingly. You can choose quantile, so it breaks this entire range of the values of the synthetic time series, which is, these are values are the PC2 values, right? So these PC2, it will break it down into quantiles and then represent the symbols based on those quantiles. As we discussed during our previous video, what it does is that you have to choose the distribution, right? So piecewise aggregate approximation, the mean values are then thrown into the distribution of our choice over here. So distribution, once we choose normal, then it will choose like a normal Gaussian distribution, and then it will start putting all the mean values and then plot those mean values and represent. Those mean values are not used anymore, but they get represented in terms of the probability density function, basically. And from the charts of the probability distribution of the Gaussian distribution, then those values of probability are assigned a symbol. And because we have taken 6 bins, the probability from whatever it comes from, like the tail probability of nearly 0 or infinity, rising to the peak and going to the other side of the tail to 0, they will be broken into 6 bins, and then each of the probable values against these original time series will then be represented by that symbol. Then once those symbols have been assigned to the original series, you don't need the original time series anymore. You can just live with those number of symbols and the probabilities mapped to each symbol, and you can recreate the entire time series just by that kind of encoding. That's for me, it's a beautiful way of doing it, and a computationally extremely efficient way of representing a complex time series. So that brings us to an end of a very exciting topic of PAA and SAX. And hereafter, I think the next video I will just touch upon quickly on the code, how this representation of the symbolic aggregate approximation was achieved using the Python code, and then followed by the qualitative analysis of the stocks and the hypothesis that we have represented in the beginning. Thank you.